Hello everybody, my name is Connor Thompson. This is my Lab 3 report. This lab is all about observing the circular motion of objects at speeds that can be impacted by external forces, such as planetary orbits, and we have a net force due to gravity in our lab. We analyze this data through predictive models with glow script code, and this lab primarily deals with concepts in net force, velocity, position, displacement, planetary gravity, and the modeling of these concepts and the idea of a system versus surroundings. A spaceship with a circular orbiting motion, or a moon, is our system, and a space or a planet is our surroundings. Before we go any further, these are our results. So on the left side, this is our part 1 glow script code, which just shows the sun and the black hole. And this is this part 2, which has the moon orbit right here, and the spaceship that kind of slingshots around the moon once it gets here and then comes back, because it's being acted upon gravity with both this planet and the moon. This is our code for part 1. So you can see we modified time to here, or the time right here. We modified the delta t values. We modified the momentum equations just to keep it in terms of physics formulas so we can actually calculate these values. And same thing for here, we changed the time. These should be 60 times 60 times 700. I don't know why it's like that, but it should be that. We calculated these just by kind of plugging in values that should have worked. We have rate. We calculated the radius and the force equation just by using physics formulas that I mentioned earlier. And same with force and net and all of these ones over here. The background of the experiment. So this lab, like I said, is all about analyzing the circular motion of objects. And the primary equations we used are P equals mv. Sorry, I thought I mentioned it before. These are the equations we use. We use P equals mv momentum, F is dp over dt, which is just force to momentum relation. F gravity is gm1 over r squared, or m2 over r squared. And then along with updating velocity update formulas. This force of gravity was calculated using given values or arbitrary values using plug-in variables from these equations, just to give us the velocity and position once we kind of worked our way through it. And after finishing our starter code, we were able to successfully model the behavior of these objects with the two models that I showed photos of earlier. Experiment results. So the black hole mass, see this photo right here, was calculated simply using the gravity equation. We just kind of moved the variables around. R squared was calculated by using the radius of the star, or the position of the star minus the origin, and then we just kind of moved around the gravity constant, the mass 1, mass 2, until we got it in terms of just the black hole mass, and that's how we got this equation right here. And the shift speed, like I said before, was kind of just used with experimentation because it wasn't really based on accuracy, more so just to show the concept that a force is being acted upon the spaceship by both the moon and the planet. And so we just kind of played around with the variable until it gave us that general behavior. Now, what does it mean? And although on the code we can see on the right that an individual parallel and perpendicular components for change in momentum are equal to the respective net force components, as you can see right here, they are still different primarily because of what they mean. Net force represents the overall force acting on an object, in this case pointing towards the center of mass an object is orbiting around, so like the star or the planet, the black hole or the planet, while the change in momentum value represents the mass in motion value over time. Although they are equal in value due to the equation right here, they mean different things. And furthermore, the parallel and perpendicular components also have two different functions. And although parallel components like momentum act in the direction the object is moving, the force of an object in this case acts parallel, or perpendicular, because you have a planet here, you have an object here, it's going to be perpendicular to how it's moving because it's moving this way, force is this way. This makes them different in sign inequalities even though they have the same magnitude. Now, what if? What if in this model we made a function or a model that had all of the elements, the planet, the moon, the star, and the sun? Well, that would make it more accurate because although in this model right here we only have the black hole and the sun, if we wanted to make it more accurate, we would need to include everything. And although objects like the black hole and star would inflict significantly more gravity upon the other objects, if we wanted a model that had utmost accuracy, including these two other objects, the planet and the moon, and their respective gravitational forces, no matter how insignificant, we would have an overall more accurate model. Thank you for watching.